Until now, we have understood various phenomena associated with the universe, some of the celestial bodies we have seen, and some of the phenomena associated with these celestial bodies we have seen. Now we enter our own solar system. And as we all know, the central object of this solar system is our sun. The sun is nothing but a star. We discussed this, an average sized star. So, some of the facts that can be important for you, first of all, the mass of the sun and the diameter of the sun, two things that you can know, can't come in the examination directly. Third fact that we have about the sun, this becomes important. The distance between the sun and the earth. The distance between the sun and the earth is 149.6 million kilometers, approximately 150 million kilometers. This is something which is also called as astronomical unit. Now, astronomical unit is a unit of distance measurement. Whenever we measure distances in the space, we can use astronomical unit also as one of the units. You might have come across units like light year, for example, or even parsec. These are also different units of measurement of distances in space. Astronomical unit is also one of them. Whenever distances are not very huge, in that case we tend to use astronomical units, but when the distances are very huge, then in that case we normally see that astronomical units are not used, but rather units like light years or parsec can also be used. So then when we talk about light year, you might know that what is light year. The distance that can be traveled by light in 1 year is called as a light year. Similarly, you also have the concept of parsec, which is approximately 3.26 light years. So you'll see that when it comes to the measurement, parsec is more preferred unit as compared to light years. Anyway, we don't want to go there. So just understand that distance between the sun and the earth is 149.6 million kilometers, and this unit is very important. This figure is very important because this is one astronomical unit. Then light travels from sun to the earth. We all know this in 8 minutes and 19 seconds. The sun can also be called as a G25 star, and the age of the sun is about 4.5 billion years. So these are some of the facts which are important. I mean, especially these four are the facts which are more important. The first two are not that important about the sun. Moving on, when we talk about the sun, we know that the energy that is possessed by the sun, this comes because of the nuclear fusion reactions that are happening at the core of the sun. And these nuclear fusion reactions are the entire cause behind all the energy that we have on the earth, or rather the entire solar system. All the heat and light that we receive on the earth, that is coming from the core of the sun, where all the nuclear fusion reactions are happening. So let's look at this particular picture. You have the core, you have the radiative or the radiation zone, then you have the convective or the convection zone, then you have the photosphere, then you have chromosphere, and then finally you have corona. These are the various regions of the sun. Starting from the midpoint or the center of the sun, where you have the core. Core of the sun is very, very hot. This is where all the nuclear fusion reactions are happening. All the heat, all the radiation, everything is being generated at the core of the sun. So at the core of the sun, even the temperatures are very, very high. The temperatures can be as high as 15 million degrees Celsius because of the nuclear fusion reactions that are happening here. Now from here, all the heat, all the radiation, all the energy that is generated, everything is carried outward, and this happens with the help of radiative zone. So radiative zone is almost 70% of the interior of the sun, almost 70% of it. All the radiations are being carried outward towards the convective or the convection zone. Now this is a zone where we see that now temperatures have dropped. So for example, first of all, we know that at the core the temperature is approximately 15 million degrees Celsius. Then once you have reached the radiative zone and you are going towards the convective zone, at the end of radiative zone you have temperature of approximately 1 million degrees Celsius. So temperatures have dropped significantly now. Then after that, once you move from the convective zone towards the photosphere, photosphere is something you can imagine as the surface of the sun. This is where the atmosphere of the sun begins from. So you can imagine it's just like the crust of the earth, the surface of the sun. So here the temperature has dropped significantly, and at this point we see that temperatures are approximately 5500 to 6000 degrees Celsius. This is the temperature that is observed at this point. Photosphere. So photosphere is what you see as the sun. The yellow colored sun that we see, This is nothing but the photosphere. Now, after that, we come to the atmosphere of the sun, where you have two parts, chromosphere and corona. So chromosphere is reddish in color. As you can see, the red ring that you see in the picture, this is the chromosphere. So normally this chromosphere will not be visible. But whenever you have eclipse, whenever you have solar eclipses, the ring-like structure that you see, the ring that you see for the sun, that is basically the chromosphere and the corona. So chromosphere is only visible at the time of solar eclipse. Otherwise, because of the brightness of photosphere, the chromosphere is not visible. Now, what happens here is peculiarly very important. The temperatures have dropped to approximately 5500 to 6000 degrees Celsius in the photosphere. Normal logic says that as you are coming out of the sun, the temperature should further decrease. But what we have observed is that the temperature rises from here. The temperature rises, and at the edge of chromosphere, the temperature is approximately 50,000 degrees Celsius. So something which is very out of the ordinary, something which is very peculiar, but we don't know why this happens. We still don't have an answer to why exactly this sudden rise in temperature happens when it comes to the atmosphere of the sun. Then after that, once you reach the corona, the outermost layer of the atmosphere of the sun, here the temperature again rises to approximately 1.5 to 2 million degrees Celsius. So we have gone back to the temperatures which were there at the border between radiative zone and the convective zone. So why this happens, what is the reason behind this kind of an increase in temperature, is something that we don't know. We do have a probe that was launched for the sun, the Parker Solar Probe. The Parker Solar Probe is also trying to look at this particular phenomena, that why exactly something like this happens, because at this point of time it is not known why it happens. Even Aditya L1, the sun probe that we are launching, ISRO is launching, this also is going to try and look into the phenomena of this increase in temperature and why exactly the increase in temperature happens in the sun. Now then, there are certain phenomena which are associated with the sun which also become very important from your prelims perspective. These are sunspots, solar flares, and solar winds. So let's try and understand what is the meaning of all these terms. First of all, you have sunspots. Now, if you observe the first picture, you can see that there are dark spots that are visible on the surface of the sun. These dark spots are called as sunspots. Now, why does this happen? Many a times what happens is that the magnetic field that is there inside the sun, it is not able to escape the sun. It gets trapped inside the photosphere. And once it is trapped, because of the fact that it is trapped, we see that not enough energy comes to the surface at this point of time. And because of this very fact that not enough energy has come to the surface, we see that the temperatures at this region is lesser as compared to all the surrounding regions. So for example, if all the surrounding regions have a temperature of approximately 5500 degrees Celsius, then in that case, the sunspots have a temperature of approximately 4000 degrees Celsius. So maybe in the range of 35, 3700, 4000, 4200 degrees Celsius. But largely what you will observe here is that the temperatures will be approximately 1500 to 2000 degrees Celsius lesser as compared to all the surrounding areas. So this is something which is also called as sunspots. Then after that, you have another phenomena which is called as solar flare. What happens is, because of the sunspots, many a times we see that all the surrounding areas see a large amount of magnetic anomaly. And because of this magnetic anomaly, we see that these areas appear to be very bright regions, brighter compared to everything else in the surrounding. And because of these solar flares, we see that high amount of energy is released from these areas. So whenever these are released, whenever solar flares are released, they can even interact with the magnetic field of the earth, and they can cause disturbances even on the earth. Our communication channels can be disrupted because of solar flares. Now, when it comes to solar flares and sunspots, what we have observed is that both of these are phenomena which follow a 11-year cycle. That is, if, for example, sunspots have appeared here at this particular point, then the next time sunspots will appear at this very point will be 11 years from now. There can be many other sunspots that will keep on forming, but these sunspots will form in the different areas of the sun. But in the exact same spot, the sunspots will appear back after 11 years. This is something which is also, that's why, called as solar cycle. This 11-year cycle, what happens after every 11 years is that the magnetic poles flip. The north pole of the sun becomes the south pole, and the south pole of the sun becomes the north pole. And this again happens every 11 years. That's why this complete phenomena is also called as solar cycle. Now, with solar cycles, there are two more terms which are associated. One which is called as solar minimum, and then you have the concept of solar maximum. So what happens is that whenever you have solar minimum, the activities of the sun are minimum. That is, number of sunspots will be the least, number of solar flares will be the least. So all these things will be very calm. So this calmness is called as solar minimum. Then after that you have solar maximum. Solar maximum is when you have a large number of sunspots appearing in different regions of the sun. So large number of solar flares also being formed. So activities of the sun are on a rise. So this is something which is called as solar maximum. So normally we see that solar minimum is observed at the beginning and the end of the cycle. That is the 11-year cycle that we are discussing here. At the beginning and the end of the 11-year cycle, this is where we see solar minimum happening. And at the center of this 11-year cycle, we see that solar maximum takes place. So these are phenomena associated with the sun, solar minimum and solar maximum. Now, one more concept that you may come across in the newspapers is coronal mass ejection. In short, it is called as CME. Now, coronal mass ejection is basically associated with the same concept of solar flares. That when solar flares are happening, at this point of time, ejection of coronal mass can happen. That ejection of subatomic particles like protons, electrons, etc. can happen. So these ejections are called as coronal mass ejections. Then there is another concept, for example, what you see here, when this kind of an appearance happens, this is also called as prominence. So I'm just giving you all these terms because many a times there are possibilities that a direct prelims question comes from here. So that's why just remember all these terms, just understand their meaning in one line and one line only. That's it. So prominence is another concept which is associated with solar flares, that this kind of a thing happens on the surface of the sun. We don't know why exactly prominence happens, but just that it has been seen that whenever sunspots are present, whenever solar flares are formed, at the same time prominence can also be observed. Then lastly, you have solar winds. So solar winds are nothing but huge magnetic winds that take up from the sun. For example, if you look at this particular picture, this is what solar wind is. That solar winds will originate from the sun and they can actually interact with the magnetic field of the earth as well. Right? Because even our earth has a north pole and a south pole, and we know that earth also is magnetic in nature. So solar winds, which are magnetic storms which are coming from the sun, they can also interact with this magnetic field of the earth. And when they interact, there are some distortions again which can happen in the electromagnetic communications. Not only this, when we talk about aurora borealis, this phenomena is also caused because of solar winds. Now understand that solar flares can also cause auroras, and solar flares can also cause disruptions in the communication systems. The difference that you have when it comes to solar flares, what we discussed is that solar flares appear once in 11 years, and solar flares will only affect the earth and everything associated with the earth only if these solar flares are coming in the direction of the earth, because sometimes they will be away from the earth, sometimes will be in any other direction. So in those cases we will not see that there are any disruptions that are caused because of solar flares. But solar winds are uniform. Solar winds are originating from every point on the sun. So that's why solar winds have more problems associated with it as compared to solar flares when it comes to the earth. Now, one more fact that scientists have been saying is that when it comes to Mars, Mars does not have a good atmosphere, almost a depleted atmosphere. The reason behind the depletion of the atmosphere of the Mars is said to be solar wind. That strong solar winds have eroded the atmosphere of Mars, because originally also the atmosphere of Mars was not as thick as you have seen on Venus or Earth. It was little thinner, And because of that, once it came across solar winds, it was not able to withstand solar winds, and the atmosphere of Mars eroded. So this is one of the theories about erosion of atmosphere on Mars. So these are some of the phenomena associated with the sun which are important. And given, because of all the discussions in and around Aditya L1, sun as a topic is also going to be very, very important for your examination as well.